So today marks the day that we have started our cell unit, and we're actually going to be in this unit for quite a long time. And before we can really talk about cells, we need to talk about chemistry and biology, because the cellular level actually starts at the molecular level. So you will need to write chapter 6, chemistry and biology. And this is a pretty large chapter. There's 4 sections, so make sure you write it all down. Chapter 6, Chemistry and Biology. Section 1, Atoms, Elements, and Compounds. Section 2, Chemical Reactions. Section 3, Water and Solutions. Section 4, The Building Blocks of Life. The big idea of Chapter 6 is atoms are the foundation of all biological chemistry and the building blocks of all living organisms. So up to this point, you've heard cells are the building blocks of all organisms. And while that's true, it's actually chemistry that are the building blocks of the cells so that the cells can be living organisms. The main idea of each of these sections: matter is composed of tiny particles called atoms. Chemical reactions allow living things to grow, develop, reproduce, and adapt. The properties of water make it well suited to help maintain homeostasis in an organism. Organisms are made up of carbon-based molecules. Again, this video is for my biology students, not physical science. Essential questions, you do not need to write those down. You can always refer back to the video, but if you'd like to write them down, your book, your choice. Lesson 6.1, Atoms, Elements, and Compounds. So we're going to be on this chapter for a total of 309 minutes of class time. That doesn't count evenings and notes and your own personal study time, as each person is different. So my suggestion to you is that you begin making your note cards and you start writing things down and doing the studying that it's going to take, because cells and the chemistry of cells is a huge, I would say it's at least half, if not 3/4 of your EOC, as well as your midterm and your final exam for my class this year. So make sure you start studying now and not wait until the last minute. So our first heading, atoms. The structure of an atom. Atoms are the building blocks of matter. They're made up of smaller particles called neutrons, protons, and electrons. Protons are positively charged. Neutrons are neutral. Electrons are negatively charged. So here's the structure of an atom as can be found on page 184 of your book. Protons and neutrons are located at the center of the atom, called the nucleus, and electrons are located on the outside of the nucleus. After you get done with these 2 bullet points, I need you to just draw a simple structure. Just draw 2 different colors of little balls here clustered in the middle. These are going to be your nucleus, and you're going to point that you have neutrons as well as protons, and then out here dancing around in this little cloud is your electrons. On your own time, please check out the Atomic Structure Brain Pop, Mr. Moby, Tim and Moby, on your resource, on your online textbook. Elements, next heading. An element is a pure substance that cannot be broken down into any other substance by physical or chemical means. And you need to know there are over 100 known elements, 92 of which occur naturally. Each element has a unique name and symbol. So you thought chemistry was over. Well, surprise! Here it is again. Chemistry and the periodic table simply do not go away. So make sure you write down the periodic table of elements is a horizontal row called periods that is also made up of vertical columns that are called groups. As you remember from chemistry, isotopes are atoms of the same element that have the same number of protons and electrons, but they have different numbers of neutrons, and we call those isotopes. Radioactive isotopes Changing the number of neutrons in an atom does not affect the charge, but does affect the stability. When a nucleus breaks apart, it gives off radiation that can be detected and used for many applications. Isotopes that give off radiation are called radioactive isotopes. A compound is a pure substance formed when two or more different elements combined. Compounds are always formed from a specific combination of elements in a fixed ratio. Compounds cannot be broken down into simpler compounds or elements by physical means, but can be broken down by chemical means. So for example, sodium chloride, that's a common one. We took chlorine, we took sodium, both of them deadly, but once mixed together, it tastes rather nice on your steak. So I've made a chemical compound. Well, what's the glue that holds those things together? And we call that a chemical bond. So make sure you're writing this down, please. A chemical bond is the force that holds substances together. The electrons of an atom are responsible for forming chemical bonds. Electrons travel around the nucleus of an atom in areas called energy levels. Atoms become more stable by losing electrons or attracting electrons from other atoms. One type of bond is a covalent bond, the chemical bond that forms when electrons are shared. A molecule is a compound in which the atoms are held together by covalent bonds. For example, the water molecule. Pages 152 and 153 are really great references for pictures. Ionic bonds, an atom that has lost or gained one or more electrons, is an ion. For example, have you ever heard that opposites attract? Okay, somebody that's happy is attracted and wants to be with somebody who is not happy. Okay, opposites attract in relationships. So I always say, isn't it ionic? Get it? Ironic? Anyway, bad joke, but it'll help you remember. Ions carry an electric charge, and an ionic bond is an electrical attraction between two oppositely charged atoms. And here's the example of sodium and chlorine before the transferring of their atoms that makes it positive and then negative, and to get the compound sodium chloride.
An ionic bond is an attractive force that holds two oppositely charged ions together. Ionic bonds are in many substances that you're familiar with, such as sodium chloride or salt. A sodium atom has 11 electrons with the outer level holding 1 electron. A chlorine atom has 17 electrons with the outer level holding 7 electrons. The sodium atom loses 1 electron to the chlorine atom. Because the sodium atom lost 1 electron, it now carries a positive charge and is a positive ion. The chlorine atom now contains 8 electrons in its outer level and is stable. Because the chlorine atom accepted 1 electron, it now carries a negative charge and is a negative ion. The compound sodium chloride illustrates how the attractive forces between two ions of opposite charge, in this example sodium and chloride, produce an ionic bond. Who knew ionic bonds were so important? In fact, ions play an important role in the maintenance of homeostasis, and they help transmit signals among cells so that you can hear, feel, taste, and smell.
So a good way to remember how does it become positive or negative, especially if you've always struggled with that. I always say, hey, it's a good thing, it's a positive thing to give things away. If you're a giver, and you're a giving person, that's a positive thing. So if an element is giving up an electron, okay, he's giving it away, that makes that element now positive. And, you know, they always say, hey, don't be greedy. So if you're the person who always takes all the time from everybody and you never give anything up, and you're always a taker, okay, not a giver, then that can become a very negative thing. So that would mean the element that is taking away something from somebody else or another element ends up becoming negative.
About chemical bonds, how elements can join to form compounds. I think to help us understand these concepts in ionic and covalent bonding, we need to review some basics of the atom. If If I have a hydrogen atom, inside we have the nucleus, and hydrogen has one proton, and then outside of it, protons equal electrons. It'll have one electron on the outside. Usually it has one neutron, but neutrons can change. In covalent bonds, there's a sharing. In the sharing example here, we have one electron in hydrogen and one electron in the other hydrogen, and these two share this hydrogen. This is how we find hydrogen in nature, as H2. So both outer orbitals are full. Atoms have a tendency to want to have their outer orbitals full. 2 in the first orbital and 8 in the second. Here's another example with a double bond. Oxygen has 6 outer shell electrons, and since both have 6, they share 4 here for a total of 8. In the case of nitrogen, we have 5 outer shell electrons in each element, and they come together and share the 6 in a triple bond. Our other type of bond are bonding, ionic bonding. In sodium, we have 1 outer shell electron. Chlorine, which has 7 outer shell electron, needs 1. So in the diagram, you can see the electron being given. This atom has a positive charge, and this atom has a negative charge, and this causes them to be attracted to each other. We have now created the compound salt.
This would be the first part of your lesson 6.1.